Okay, to prove Arrow's theorem, we're going to first prove an important lemma called the spread lemma. But before we even state the spread lemma, we need to recall an important notion, and that's the notion of decisiveness. And recall what it means for a group to be decisive about a question. So let's split this total. So here we have the whole population, and let's say this group G is decisive about the question of whether A is better than B or vice versa. What it means for that group to be decisive is this if they are unanimous about how to order A and B, so each individual thinks A is better than B, then no matter how these other two come down in the question, maybe they both think B is better than A, maybe one thinks A is better than B, their preferences don't matter. If this group is decisive about this question and they all rank A better than B, then the group as a whole prefers A to B. That's what it is to be decisive about a question. And what we're going to show now is that if the group is decisive about any question, this subgroup is decisive about any question, then they're decisive about every question. So if we give them a little bit of power, the power to decide for the group whether A is better than B, then we actually give them a lot of power. We give them the power to decide for the group, for example, whether C is better than D for any other two options that we pick. So it's called the spread lemma because this bit of power spreads to all options. They end up becoming decisive about all options, all questions. Okay, so that's what we're going to prove. And what we're going to end up doing, and it's a little bit of a funny strategy, is looking at a very specific case and then using axioms like the independence of irrelevant alternatives to tell us what the group preferences must look like in other cases as well. And that's how we're going to establish that decisiveness spreads from one question to every question. So I'm going to start off with some very specific assumptions, but then we're going to use these other axioms to say, well, actually those initial assumptions, they tell us something about more than just that one specific case. They tell us about a bunch of different cases. Okay, so let's say we have a group here. We've got two individuals, and let's just make there be one person outside of the group just for simplicity. But we could have any finite number of individuals in this group, not just two. We could have any finite number of individuals not in the group, but in the wider population. We could have 100 out here. We don't just have to have one. But now let's imagine that this group is decisive about some particular question. So in particular, let's say that the whole population has preferences about four different flavors of ice cream. Let's say vanilla, strawberry, chocolate, and pistachio. And so individuals will have different preferences over these types of ice cream. The group will have a preference as a whole for different types of ice cream. And let's imagine at the outset that this group, G, is decisive about the question of whether, let's say, pistachio is better than strawberry, let's say. So let's give them a little bit of power. Their opinions, if they're unanimous about whether pistachio is better than strawberry or vice versa, then the whole group, not just these two, the whole group will share their opinion. And then what we're going to do is we're going to show that this decisiveness spreads to other questions. So in particular, whether vanilla is better than chocolate. That they're going to end up being decisive about that too. Okay, so right now we're assuming they're decisive about whether pistachio is better than strawberry. And now I said we're going to look at a very specific case and then use our axioms to draw some conclusions about what happens in other cases as well. So let me tell you more about this specific case in question. Let's imagine that both of these people in this group, they like vanilla better than strawberry, and they like strawberry better than pistachio, and they like pistachio better than chocolate. So both of these individuals have this same preference ordering, okay? And now let me put two different preference orderings that this person could have. We're not going to settle on one right now, so we're really kind of considering a pair of cases, one where they have the first preference ordering, one where they have the second. So two possible preference orderings. One has them liking exactly the same things that that the people in the group like here. So they like vanilla better than strawberry, they like strawberry better than pistachio, and they like pistachio better than chocolate. The other preference ordering that they could have that we'll consider is they like pistachio best. Pistachio's on top, and then chocolate second best, and then vanilla third best, and then strawberry last. Okay. Now, we're going to use first the Pareto principle to deduce some facts about what the group preferences must look like. So the first thing I want you to notice is that everybody in the whole population, they like vanilla better than strawberry. So you go all the way down the line, whichever one of these two we pick. Everybody, all three of these people like vanilla better than strawberry. And so the group must like vanilla better than strawberry. That's one consequence of the Pareto principle. Now let's do the same thing for pistachio and chocolate. Notice that both of these individuals like pistachio better than chocolate, and whichever preference ordering we pick here, this person outside of this little group also likes pistachio better than chocolate. So everyone likes pistachio better than chocolate, and so the group must like pistachio better than chocolate by the Pareto principle. Okay, now what else can we conclude? Well, we assumed at the outset that this group, these two people, were decisive about the question of whether pistachio was better than strawberry. So if they're unanimous about how to order pistachio and strawberry, then that's what the group will think as well. It doesn't matter what this person thinks about pistachio and strawberry. And look, they both agree strawberry is better than pistachio. So they both think strawberry is better than pistachio, and since they're decisive about that question, the group must think strawberry is better than pistachio. But now look what we have. We have vanilla being better than strawberry, strawberry better than pistachio, pistachio better than chocolate. Let me draw that out like this. Chocolate, pistachio, strawberry, vanilla. So we have vanilla being better than strawberry. We have strawberry being better than pistachio. We have pistachio being better than chocolate. And so we've got a chain here, and we assumed that our group preferences were transitive. So that means that because you like one thing better than the next, that better than a third, that better than a fourth, then you must like the first better than the fourth. So what we end up with is the group in virtue of making all these pairwise comparisons, this group must like vanilla better than chocolate. Okay? So far we've just used the Pareto principle, we've used the decisiveness of our subgroup about the question of pistachio and strawberry, and we've used the transitivity of the group's preferences to conclude that the group must like vanilla better than chocolate. Now there's one last step. The independence of irrelevant alternatives told us that if you end up liking vanilla better than chocolate in one case, then actually you can erase the things other than vanilla and chocolate. Oops. Rewrite chocolate there. And however you fill in the rest of the picture, wherever I put pistachio, wherever I put strawberry, if I continue to rank these things, each individual continues to rank vanilla and chocolate in exactly the same way, then the group will end up ranking vanilla and chocolate in exactly the same way. So, however we fill out the rest of the picture, we're going to maintain this ranking if we maintain these rankings. And now look at what we have. We have whether or not this person ranks vanilla over chocolate or chocolate over vanilla. The fact that this group unanimously ranks vanilla over chocolate forces the group as a whole to like vanilla better than chocolate. And that holds no matter how we fill in all the other stuff about pistachio and chocolate. So now we've used the independence of irrelevant alternatives to tell us something not just about that initial case that we started with, but about any case where you hold these rankings of vanilla and chocolate fixed. And in effect now what we've shown is that this group is decisive about the question of whether vanilla is better than chocolate. And you can repeat this trick not just for vanilla and chocolate, but for any two things that you like. And so what we've now established is that if you start off being decisive, a group starts off being decisive about one question, say whether pistachio is better than chocolate, then they'll be decisive about every question. They just get to settle what the group thinks about any pair of options. Okay, so they actually have a lot of power. Now in the next video, we're going to use this spread lemma to prove something called the contraction lemma, and then we're going to eventually use that to prove Arrow's theorem.